Hello everyone, today I'm going to introduce my final topic, which is visual exploration in immersive environment. So what I'm trying to do is first, I will use the brainwaves to determine the gesture direction. So first step is going to use Muse2 headset to collect the EEG waves from me when I was doing the imaginary head movements, and then apply the CSP and LDA to recognize the head directions from the EEG data. And after that, I'm going to send the signals to the HoloLens to control the AR device. But since we have limited budget, instead of sending the signal to the HoloLens to control the AR, we actually send the signal to the personal computer and to control the personal computer mouse. So the next step is to use the data which from the EEG result and to slide and examine the MRI image. So before we doing the examine the MRI images, we are applying the GAN and to remove the noisy from the MRI images, and then use the EEG output result to slide and examine the MRI image slide by slide. So so for the MRI, this is a non-invasive tool for medical diagnosis, which is offering a high spatial resolution image to detect the brain soft tissues and the pathologies. However, MRI are very susceptible to a corruption due to motion and noises. So the traditional methods are restricting the subject motions or reduce acquisition time, or apply the MRI navigator motion tracking system, or apply all different kinds of filters from the case space. But what we are going to do is we use the headset and then receive EEG signals from the Muse2 and then apply that on the AR goggle. But instead of apply to the AR goggle in my project, I'm going to apply that in the personal computer to and to slide the MRI image. So, and also the MRI image will be analyzed by the GAN. Why this is important for this technology? Because it's very important for tumor examination for doctors, because clear images can clearly define the location and the size of the tumor for the surgery, and failures may cause a second brain surgeries. So why do I want to use again to analyze the MRI? Because because for the MRI artifacts or the noisy on the MRI, they have all different kinds of reasons. Maybe it's caused by the MRI machine itself, or maybe it's caused by the voluntary movements for the subjects. But the GAN will solve all those, will remove all those noise. It doesn't matter which conditions come from. So that's why it's used GANs. And and this is our data set preparation, and we will have train and a test. And for training, we will have both of the data sets have two folders, which are input image or ground truth images. And we will input, we will train the discriminator with the real image, and train the generator with a fake image, and eventually the generator and discriminator will compete with each other, and after thousands of trainings, the generator can generate good enough quality images, which is just like real image. And so after we get the image from the generator, so and we will put them into the folder, which will be ready for the examinations. So for the EEG part and how that works, so we use the Muse2. So this is the machine we use here, and the Muse2 only have 4 electrodes, and the shortcomings is you have a less electrodes can be used, which are can cause measurement will be less precise. But the good thing is we can make the AR goggle more portable, which means we can combine this Muse2 style device into the AR goggle, because they only require 4 electrodes. And then after we collect the data from the Muse2 and we do the LDA classifier, and we classify the we classify we classify the signals, and the signal is from the head movement. The movement as LDA can help us to tell which head is moving, is left or right. So I will show you how that works. So this is the data which is output from the generators, and we can run our code, which is a mouse control code, and try to move this without hands. Okay. Okay. So this is how it works. And for the future application, so since we have limited budget, we didn't apply this technique on AR, but it's easy to apply this technology in the AR goggles or device, and this technology will have a huge potential in many fields, which are the biomedical examination and surgeries, which I just show you, or the educations, immersive gaming, new social media, industry trainings, new communications, or any work exhibitions. So all these kind of potential fields can be applied. And this is my reference. Thanks.